Alright, so you've probably heard of induction motors. They're basically the unsung heroes that power everything from your washing machine to massive industrial fans. But what actually makes them tick? Let's break it down, step by step. First up, the basics. An induction motor is an AC electric motor where power is supplied to the rotor by electromagnetic induction, not by direct connection. That's a mouthful, but here's what it means. There are two main parts, the stator, which stays still, and the rotor, which spins. The stator is made up of coils of wire arranged in a circle. When you run alternating current through these coils, they create a rotating magnetic field. Imagine the magnetic field as an invisible merry-go-round, spinning at the frequency of your power supply. Now, the rotor sits inside this stator. It's usually a bunch of conductive bars like aluminum or copper, shorted at both ends by rings. This whole setup is called a squirrel cage rotor because, well, it kinda looks like a hamster wheel. Here's where the magic happens. The rotating magnetic field from the stator sweeps past the rotor bars. According to Faraday's law, this changing magnetic environment induces a current in the rotor bars. And thanks to Lenz's law, the induced current creates its own magnetic field that tries to chase the stator's field, but the rotor never quite catches up. This difference in speed is called slip, and it's essential. Without slip, there'd be no induced current, and the motor wouldn't work. The greater the load on the motor, the more slip you get. Let's get a bit deeper. The stator's coils are arranged to create three-phase AC power, which means the magnetic field rotates smoothly, not in jerky steps. This smooth rotation is why induction motors run so quietly and reliably. And about efficiency, induction motors are rugged, have no brushes or commutators to wear out, and can handle rough environments. But they do have losses. Some energy gets lost as heat in the windings and the core, and some in the rotor itself. That's why you'll often see cooling fins or fans attached to the motor housing. Technically, you can tweak the speed by changing the frequency of the AC supply. This is what variable frequency drives, or VFDs, are for. They let you dial in the exact speed you need, which is super useful in elevators' conveyor belts. So next time you see a fan spinning or an escalator running, remember, there's a lot of physics and engineering packed inside that humble induction motor, quietly turning electricity into motion, day in and day out.